Today we're going to take a look at arc length, which is part of the circumference of a circle. Let's start with the formula for circumference of a circle, which is 2 pi times the radius. Thinking about the definition of a radian, I'm going to pull up the notes from yesterday where the definition of a radian is that the length of the arc equals the radius. So the radians can give us the arc length if the radius is 1. If the radius is not 1, we simply multiply those radians by the radius, which is exactly the formula that we have right here. So if we want the full circumference in radians is 2 pi, and then you multiply it by the radius. The other topic we're going to take a look at today is converting between degrees, minutes, and seconds. So just like an hour is broken into 60 minutes, so is a degree. So a minute is 1/60th of a degree, and a second is 1/3600th of a degree. Our main focus for today will be that arc length formula, so that's our essential question. Our formula for arc length is the arc length equals the measure of the central angle in radians. Theta is a Greek symbol that we use to represent an angle. You've probably seen it with the SOHCAHTOA, times the radius. In this case, we know theta is pi over 2, and we know the radius is 5. So the length of this arc would be 5 pi over 2 inches. Arc length is a measure like circumference, so it would be in units of inches, or whatever the units on the radius are. Notice example B, that angle measure is not in radians. In order to find the length of the arc, we will need to convert that 120 degrees to radians. So dividing by 180 degrees and multiplying by pi, and then we will multiply by the radius of 7.5 centimeters. 120 degrees is 2 pi over 3 radians times that 7.5. 2 times 7.5 is 15, and 15 divided by 3 is 5. So we would have 5 pi centimeters for the length of our arc. This time we have the arc length, and we need to solve for the measure of the central angle. So we substitute 6 for our arc length, 8 for our radius. When we divide both sides by 8, we get 3/4 for our angle. Part B, notice this time the angle is not included for that arc that we know. So we'll have to do an extra step to solve for this one. We still set that 31.7 equal to the radius times, and I'll just call it x, which would be this angle. So as not to confuse it with the actual angle that we need to solve for. Dividing both sides by 8, we get 3.9625 for the angle of rotation that is inside the arc, but we need what's not included. There are 2 pi radians in a full rotation, so we'll subtract off that 3.9625 to get an approximate value for our theta of 2.321 radians. To convert from decimal degrees to degrees, minutes, seconds, you take that fraction of a degree and you first multiply by 60. This will convert your decimal degrees to minutes. There are 60 minutes in a degree. In this case, we get 36 minutes. There's nothing left over, so we have 135 degrees, 36 minutes. If you're familiar with the units for feet and inches, they're the same units that we use for degrees, minutes, and seconds. So minutes is 1 apostrophe and seconds is 2 apostrophes. 51.23 degrees. We start by converting the decimals to minutes. 0.23 times 60 gives us 13.8 minutes. But we can convert those 0.8 minutes to seconds. There are 60 seconds in a minute, so be careful that you don't use the 3600. We've already converted to minutes. Now we want to convert the minutes to seconds. So we multiply that 0.8 by 60 again, and get 48 seconds. So we have 51 degrees, 13 minutes, and 48 seconds. Our last example, we will convert the minutes back to decimal degrees by dividing by 60, and we take those seconds, and this is where we use that 3600. This time we're converting all the way from seconds back to decimal degrees, and there are 3600 seconds in a degree. So this will give us the decimal part of our degree measure. I got 85.308 degrees, rounding to the nearest thousandth. And you have 2 U-Try questions today.